Today we'll discuss the subject about thermal engineering. So we'll discuss about the most important part in a thermal engineering, that is called boilers. So boiler is the most important part in a steam turbines, right? So what is boilers? So if you see the boilers in a simple word, we can say it as it is a closed vessel in which the steam is produced from the water by combustion of fuel, right? So it will produce the steam by the combustion of by the burning of fuels, right? It will produce the steams. So so that's why it is called the boiler. Also, it is called steam generator, right? So according to the American Society of Mechanical Engineers, a steam generating unit is defined as the combination of apparatus for producing, furnishing, or recovering heat together with the apparatus for transferring the heat so made available to the fluid being heated and vaporized. That is called steam generating unit. Now, why the steam generation is required in the boiler? Right? The steam generation is employed. These are the following purposes so that we can use the steam generator for generating more power in the steam engines or steam turbines, right? In the textile industries for sizing and bleaching, and many other industries like sugar mills, chemical industries. Also, we can use for heating the buildings in cold weather and for producing hot water and for hot water supply. The primary requirements of the steam generator or boilers are: what is the requirement? First point is the water must contain safely, and the second one is the steam must be safely delivered in desired conditions. Desired conditions means regards in needs to the pressure, temperature, and quality and required rate. What is the steam generation rate? So this is the primary requirement of steam generator, steam boilers. So there are different types of boilers. The first one is horizontal and vertical and inclinative boilers. If the axis of the boiler is horizontal, then the boiler is called horizontal, right? If the axis is like vertical, right, like this, so it is called the vertical boilers. If it is inclined, and it is called inclined boilers. So the part of the horizontal boiler can be inspected and repaired easily, but it occupies more space, right? So the vertical boiler, it requires less space area. So this is the advantage of vertical boilers. Next boiler. Second one is fire tube and water tube boilers. So in the fire tube boilers, the hot gases are inside the tubes. If you see the boilers, there is a tube and waters surrounding the tubes, right? If you see any boilers like Cochran Boiler, Locomotive Boilers, there is a tube inside is there. If inside the tubes hot gases are flowing and outside the tubes there is a surrounding by the water, then it is called fire tube boilers. For example, Cochran Boiler, Lancashire Boiler, and Locomotive Boilers. In the water tube boiler, the water is inside the tubes and the hot gases are surrounding the tubes. That is called water tube boilers. For example, Babcock and Wilcox boiler, Stirling boiler, and Aeronautical boilers. So these are the fire tube and water tube boilers. Next, externally fired and internally fired boilers. The boiler is known as externally fired if the fire is outside the cells. If you see the boilers, it contains a cylindrical cell, right? So outside the cell, if there is a fire, then it is called externally fired. For example, Babcock and Wilcox boiler and Stirling boilers. These are all called externally fired boilers. In case of internal fire, the furnace is located inside the boiler cell. That is called internally fired. Like your Cochran boilers and Lancashire boilers are called internally fired boilers. Fourth one is forced circulation and natural circulations. If you see in a forced circulation type boilers, the circulation of water takes place by a forced pump. For example, Wilcox boiler or La-Mont Boiler or Benson Boiler. These are all called forced circulation boilers. But in natural boilers, the circulation of water takes place due to the natural convection currents produced by the application of heats. For example, Lancashire boiler, Babcock boiler, and Wilcox boilers. These are all called natural circulation boilers. And the fifth one is high pressure boiler and low pressure boilers. If the boiler which produce steam at a pressure of 80 bar, if it is produced 80 bar, the limit up to 80 bar and above, these are called high pressure boilers. So Babcock and Wilcox boiler, if you see Wilcox boiler or La-Mont boiler or Benson boilers, the steam pressure produced, it is above 80 bars. So that's why it is called high pressure boilers. If the pressure is below the 80 bar, steam pressure is below the 80 bar, which will produce steam, then it is called low pressure boilers. For example, Cochran boilers, Cornish boilers, Lancashire boiler, and Locomotive boiler. These are all low pressure boilers. Next, stationary and portable boilers. The primary, the boilers are classified either stationary or portable, or it is called mobile, right? The stationary boilers are used for power plant steam, for central stations utility, for plants, for plant process steam, etc. For the mobile boilers or portable boilers inside the locomotive type and other small units for temporary use at sites. You can use any industries. We are using mobile boilers like small coalfield industries. Next, single tube boiler and multi tube boilers. The fire tube boilers are classified as a single tube or it is classified as multi tube boilers depending on the whether the fire tube is one or more than one. If it is, if you see the Cochran boiler and simple vertical boiler, inside the boiler cell there is a tube is there, fire tube is there, right? If it is a single tube, then it is called single tube boilers. If it is one tube, if it is more than one tube, then it is called multi tube boilers. So such type of examples are Cornish boilers, vertical boilers, and remaining boilers like Babcock and Wilcox, locomotive boilers. These are all called multi-tube boilers because it contains more than one tubes. Now, what is the difference between fire tube boiler and water tube boilers? So, according to the position of water and hot gases, already I have told in fire tube boilers, the hot gases inside the tubes and water is surrounding the tubes, right? But in water tube boilers, water is flowing inside the tubes, where the hot gases is surrounding the water tubes. According to the mode of firing, it is internally fired because fire tube in fire tube boilers, the furnace are inside the boilers. That is internally fired. But in water tube boilers, it is externally fired. The fire is outside the cell of the boilers. Operating pressure, if you see the operating pressure limit to 16 bar in case of fire tube boilers. Right. That's why it is called low pressure boilers. What you see in water tube boilers, it can be up to 100 bars. That's why it is called high pressure boilers. According to the rate of steam production or steam consumption, the fire tube boiler is less compared to the water tube boilers. Then suitable for more, not suitable for large power plants, right? And this is suitable for heavy power plants, more large power plants. Then if you see the floor area, fire tube boiler, it occupies less space like your vertical boilers. But in a water tube boiler, it require more space. Sorry, in fire tube boilers it require more space and water tube boilers it require less space. According to the constructions, the fire tube boiler is very difficult. But if you see in water tube boilers, it is very simple to construct. For transportation also, it is very difficult to transport the fire tube boilers. But it is easy to transport the water tube boilers. And the cell diameter is large in case of water tube boilers. Then in case of fire tube boilers, then water tube boilers. But the chances of explosion is very less in fire tube boilers than water tube boilers. So it will not necessary to treatment of water in fire tube boilers. That means we are not continuously changing the waters in fire tube boilers. The same water can be used. But in water tube boilers, the water it necessary to replace the waters. Otherwise, there is chances of explosion. It requires less skill for efficient and economic working in case of fire tube boilers, but it requires more skills and careful attentions in water tube boilers. Now, how to select a boiler? If you are going to shop and purchasing a boiler, there is some selections. So, how to select a boiler? What are the major areas you are going into the for selecting a boilers? The first point is working pressure and quality of steam. How much working pressure and how much quality of steam is required, whether it is dry condition or wet conditions or superheated conditions, and how much steam is generated. That is also very, very important for selecting a boilers. And what is the floor area? How much it will require to install the boilers, right? And accessibility for repair and for inspections. You have to see the initial cost and see the erection facilities, see the load factors. What are the load factors? And Also we have to assume the fuel and water available, and most importantly maintenance cost. When you're selecting a boiler, you have to see go for the operating cost and maintenance cost. That we have to look into the matter. Now, what is the essential? What is the requirement of a good steam boilers? The boiler should produce maximum height or maximum weight of steam of the required quality of minimum expenses, and the steam production rate should be required as per the requirements. It should be absolutely reliable. This is the advantage of steam boilers. This is the requirement of steam boilers. It should occupy minimum space or less space, and it should be light in weight. This is very important. It should be light in weight, and it should be capable of quick starting. And there should be an easy access to the various parts of the boilers for repair and inspections. Right, the boiler components should be transportable without difficulty, and the installation of this steam boiler is very simple. That also we're going to see when we're purchasing a boilers. The tubes of the boilers should not accumulate soot or water deposits and should be sufficiently strong to allow for wear and corrosions. The water and gas circuits should be such as to allow minimum fluid velocities for minimum friction losses. Next, what are the terms we're using in boilers? That is most important. The first point is cell. What is cell? The cell of a boiler consists of one or more steel plates. If you say the cell is outside the boilers, the outer part of the boiler is called cell, and it consists of a steel plate, right, into a cylindrical form and riveted or welded together. The cell ends are closed with the end plates. Next, setting. The primary function of setting is to confine heat to the boiler and form a passage of gases, right? So it is made of brickwork and may form the wall of furnace and the combustion chamber. It also provides the support in some types of boilers. For example, Lancashire Boiler. It provides supports. Next, grate. So grate, it is a platform in the furnace upon which the fuel is burned. We are burning the fuel on the grate, and grate is at the bottom of the boiler and is made of the cast iron bar, right? And the bars are arranged so that the air may pass onto the fuel for combustions. And the area of grate on which the fire rests in a coal or fired or wood fire boiler is called grate surface. That surface is called grate surface. And what is furnace? Next, the furnace is a chamber by the space which is above the grate. If you see the boiler, the furnace is above the grate. That means the grate is below the furnace, right? And below the boiler cell in which the combustion takes place. It is also called a firebox. It is also called firebox. Water space and steam space. The volume of cell that is occupied by the water is termed as water space inside the boilers. While the entire cell volume is less than the water and tubes, if any space is there, it's called steam space. And there are different types of mountings. That is very very important. What are the boiler mountings? The different types of mountings are there, like stop valve, safety valve, water level gauges, fusible plug, blow off cock, pressure gauge to measure the pressures, water level indicator. And these are all called mountings. And a boiler cannot work without these mountings. So this is the very very important parts of a boiler. Net accessories. The accessories also major parts in a boilers. The items such as the accessories like superheaters, economizers, feed pumps are much essential for the boilers, and they are the very integral part of the boilers because they increase the efficiency of the boilers. Next, water level. The level at which the water stands in the boiler is called water level. The space above the water level is called steam space. That already I have told. Foaming. The foaming is the formation of steam bubbles on the surface of the boilers of boiler water, due to the high surface tension of the water. Scale. A deposit of medium to extreme hardness occurring on water heating surfaces of a boiler because of undesirable conditions in the boiler water. Next one is blowing off. The removal part of mud, right? And other impurities. See, after burning of fuels, there is some ash bit is there, right? This is unnecessary part. So that unnecessary part from water from the lower part of the boiler is termed as the blowing off and this is accomplished with the help of blow of cock or blow of valve. Lagging. Blocks of asbestos or magnesia insulations wrapped on the outside of a boiler cell is called laggings. Then refractory, this is very very important for heating the insulation material such as fire bricks or plastic fire clay used for such purposes. The lining combustion is required, combustion chambers, that is called refractory. Now we'll discuss the different types of fire tube boilers. Already we have discussed what is fire tube boilers, right? The hot gases, if you see the fire tube boilers, see this is a fire tube, one type of fire tube boiler. This is called simple vertical boiler. So inside this vertical boiler, there's a tube is there. This is called tube, fire tube. This is called fire tubes, right? So inside the tubes, the hot gases is flowing, and the water is surrounding the tubes. That is called fire tube boilers. That already I have told. Now, if you see, these are all called mountings. This is called steam stop valve. This is manhole. This is hand hole, fire door, feed check valve. This is called grate. So this is the furnace, firebox, and the furnace is above the grate, and this is called ash pit. After burning of fuel, the ash pit is the impurities, the unnecessary part is collected in the ash pit, right? This is cylindrical cell. The outer part is called cylindrical cell, CS, cylindrical cell, and this is the level of water. This is the water level gauge, and this is the pressure gauge, and this is the stop valve. So these are all called mountings of the boilers. This is very very important. So without mountings, this boiler cannot work properly. So first one, fire tube boiler is simple vertical boilers. If you see the simple vertical boiler, it consists of a cylindrical cell, and the greater portion of which there is a full of water. If you see the greater portion, there is a full of water, which is surrounded by a firebox, and the remaining part is called steam space, right? At the bottom of the firebox, if you see, is grate on which the fuel is burned. This is the fuel. This is the fire door where entering the coals or fuels produce the fuels into this fire door where the fuel is burned, and the ash from it falls in the ash pit, right? And the firebox is provided with the two cross tubes. If you see here, one tube is here and this is another tube. Two cross tubes are there. This increases the heating surfaces. Why these two? Why the tubes are crossed, not horizontal? Because this increase the heating surface and the circulation of water. If you see, the heating surface here will be more, and the circulation of water is flowing freely. This is the purpose of doing the inclined tubes, not straight tubes. And the cross tubes are fitted inclined, and this ensures the efficient of circulation of water. So at the end of each cross tube, there is a hand hole is there. If you see, to give the access for cleaning purposes. Every time we have to clean. After completing the experiment, we have to clean the tubes. That's why for that purpose, we are giving a hand holes. Now the combustion of gases after heating the water and thus converting into steam, it will convert into the steam, and it is escaped to the atmosphere through this chimney. This is called chimney, and the steam is escaped to the water atmosphere through this chimney. And the manhole here is provided to clean the interior part of the boiler and the exterior of the combustion chamber and the chimney. So already I have told these are the various mounting parts of the boilers: pressure gauge, water level, manhole, stop valve, and steam valve. This is the working principle of simple vertical boilers. Another type of fire tube boilers is called Cochran Boiler. So what is Cochran Boiler? If you see, these are all called mountings. Already is there. Steam stop valve already I have told in the previous sections. So it is one of the best type of now see here we're using multiple tubes. There's a multiple tubes, right? So this is called multi-tube boilers, multi-tube fire tube boilers, fire tube Cochran boilers. So it is one of the best type of vertical multi-tube boilers, and the number of horizontal tubes, right? And it consists of a cylindrical cell with a dome shape. If you see, it is a dome shape where the space is provided more for producing steam. The furnace is one piece construction and it's seamless, right? And its crown has a hemispherical shape. If you see here, it is the furnace is hemispherical in nature because there is a more heating space. If you see in hemispherical, it will provide the maximum volume of space for heating purposes. Now the fuel is burned. Here there is a hole is there, fuel hole. Here we are entering the fuels. The fuel is burned using this furnace, on the grate, and ash is collected and disposed in the ash pit. And the gas of combustion produced by the burning of fuel enters into this combustion chamber, where it is contact with the fabric line. Here, this is a fabric line is there, and this fabric line which will directs this steam to pass through this number of tubes, of the horizontal tubes, which is surrounded by a water, right? So after which this gas escape to the atmosphere through this smoke box through the chimney, and the number of handhole is provided to clean the interior part of the boilers. So these are the all boiler mountings that already we have discussed. So this is all about Cochran boilers. Next, Cornish boilers. So this boiler is first adopted by a Cornish engineer, the name called Trevick, right? At the time of introduction of high pressure steam to the early Cornish engine, and it is still used. So it consists of a cylindrical cell with a flat end through which passes a small flue tubes containing the furnace. The production of combustion pass from the fire grate to forward over the fire brickwork bridge to the end of the furnace tubes. They then turn by the two side flue tubes. See here, there is a flue tubes and there are two slide flue tubes, right? Then it turned to a two slide flue tubes to the front end of the boiler and again passed to the back end of the boiler. The various of the boiler mountings already I have told: steam stop valve, pressure gauge, water gauge, fusible plug, blow of cock, high pressure flow, water safety valve, feed check valve, and manhole. And the advantages of possessed by this type of boiler is that the sediment content in the water falls to the bottom, where the plates are not brought into the contact with the hottest portion of the furnace gases. The reason for that, carrying the product of combustion first through the side flue and lastly through the bottom flue, is because the gases having parted with some much of their heat by the time they reach the bottom flue, and are less reliable to the unduly heat the plates in the bottom of the boiler where the sediment may have collected. Next, Lancashire boiler. So this type of boiler is very reliable and very simple in design and easy of operations and less operating or maintenance cost. It is most commonly used in sugar mills and textile industries, where the long along with the power steam and steam for the process work is also needed. In addition to this, boiler is used where the larger reservoir of water and steam are needed. And this Lancashire boiler also consists of a cylindrical cell inside which the two large tubes are placed, right? And the cell is constructed with several rings of cylindrical form, and it is placed horizontally over the brickwork, which forms several channels for the flow of hot gases. And these two tubes are also constructed with several rings of cylindrical forms. They pass from one end of the cell to the other end and covered with the water. The furnace is also placed at the front end of each tube, and they are known as furnace tubes, right? The coal is also introduced through the fire hole into the grate, and there is low brickwork for fire weeds at the back of the grate gate to prevent the entry of the burning coal and ashes into the interior part of the furnace tubes. So this is the schematic diagram of Lancashire boiler. So this is the fire door, this is the fire grate, and this is flue tubes, and this is there are two flue tubes, right? And these are all called mountings. The first point is called high steam low safety valves. Second is called manhole. We are giving anti-priming pipe, steam stop valve and safety valve, pressure gauge, feed check valve, water gauge, blow off cock, and fusible plug. These are all called boiler mountings. And the combustion products from the grate pass up to the back end of the furnace tubes and then in the backward directions. You see, there is a backward directions, right? So then they move through the bottom channel or bottom flue up to the front end of the boiler, where they are divided and pass up to the side flues. Now, the these are moved along with the two side flues. If you see, the burning of fluids are moving in the side flues and come to the chimney flue, from where they lead to the chimney. To control the flow of hot gases to the chimney, the dampers are provided. As a result of that, the flow of air in the grate can be controlled. Due to these dampers, you can control the flow of air. The next type of boiler is locomotive boilers. If you see, it is mainly employed in a locomotive, though it may also be used as a stationary boilers, right? And this is mainly compact, and its capacity of the steam production is very high for its size, as it can raise the large quantity of steam rapidly. So these are the specification of locomotive boilers. If you see the dimensions and specifications, the barrel diameter we are using is 2.095 meter, and the length of the barrel is very high, 5 meter, and the size of the tube, that is called superheater tubes. We are taking the diameter of superheater tubes, that is called 14 centimeters, and the number of tubes we are using is 38 in locomotive boilers. Right? And the working pressure is 14 bar, and the steam capacity which it produce, that is very high, 9,000 kg per hour, and the area of grate is 4.27 meter square, and the heating surface is 271 meter, and the efficiency, this efficiency of locomotive boiler generally gives 70%. So this is the schematic diagram of locomotive boilers. If you see, the locomotive boiler consists of a cylindrical barrel with a rectangular firebox. This is a rectangular firebox, right, at one end, and the smoke box at the other end. And the coal is introduced through the fire hole into the grate, which is placed at the bottom of the firebox. And the hot gases which are generated with the burning of coal is deflected by an arc of fire bricks. Is deflected so that the wall of the box may be heated properly. And the firebox is entirely surrounded by water, except for the fire hole. And the ash pit, which is situated below the firebox, which is fitted with the dampers at its front and back end of the boilers. The dampers are control the flow of air to the grate. Right. The hot gases pass from the firebox to the smoke box through a series of fire tubes. There is a series of fire tubes are available, and the hot gases passing through this firebox to the smoke box through these tubes. Right. And the hot gases, and then they are discharged into the atmosphere through the chimney. Through this chimney, they are discharged to the atmospheres. The fire tubes are placed inside the barrel. So some of these fire tubes are also larger diameter, right? And the other are smaller diameters. The superheater tubes are placed inside the fire tubes of large diameters. The heat of hot gases is transmitted into the water through the heating surface of the fire tubes, right? And the steam generation collected over the water surfaces. If you see, there is a dome shape is there, right? Here, the dome shape of the chamber known as steam dome is fitted on the upper part of the barrel. This is the dome shape, upper part of the barrel, from where the steam flows through the steam pipe into the chamber. The flow of steam is regulated by a means of regulator. So from the chamber, it passes through the superheated tubes and returns to the superheated steam chamber, from which it is led to the cylinders through the pipes, one to each cylinders. So what are the advantages of these locomotive boilers? It gives high steam capacity and low cost of constructions. It is portable boiler or mobile boilers, not stationary boilers, and it has low cost installations, and it is very compact. If you see the demerit, the locomotive boilers is difficult to clean some water spaces, and large flat surface area is needed. It is a horizontal boiler. It requires large space to install. It cannot carry high overloads without being damaged by the overheatings, and there are very practical constructional limits for pressure and capacity which do not meet the requirements. So these are some the advantages and disadvantages of locomotive boilers. Next boiler is Scotch boiler, and this is the schematic diagram of Scotch boilers. So here, if you see the Scotch boiler, there is a chimney is there, right? And this is the cell of the boiler, outer cell of the boiler. And why is the this is the chimney? This is the outer cell of the boilers, and Y is the bar tray, and H is the fire holes. You see here there is a fire hole. We are giving the fire for the burning of the fuels. we're providing the fuel, and this is the combustion chamber, and this is the smoke box, right? So the Scotch boiler or marine boiler, marine boilers is probably the most popular boiler for steaming capacities up to about 1000 kg per hour and a pressure of about 17 bar. And it is of compact size and occupies very less floor area. This Scotch boiler consists of a cylindrical cell. It also consists of cylindrical cell in which are incorporated 1 to 4 cylinders, right? And the furnace are internally fired. Here the furnace are internally fired. If you see, the furnace is inside the boilers. So this is a one type of example of internally fired boilers, right? Which is surrounded by a water. That means we can say it is a fire tube boilers. The combustion chamber is located at the back end of the furnace, right? Back end of the furnace, and is also surrounded by a water. Usually each furnace has its own combustion chamber. The nest of fire tubes run from the front tube plates to the back tube plates. The hot gases produced due to the burning of fuel move to the combustion chamber. These are the hot gases produced due to the burning of fuel move to the combustion chamber by means of the draught. Then they travel to the smoke box through these fire tubes, which is generally surrounded by a water, and finally leave the boilers through this chimney. If you see in a double-ended Scotch boilers, boiler furnaces are provided at each end. They look like a single-ended boilers placed back to back. But a double-ended boiler of same evaporation capacity is cheaper and occupies less space as compared to single-end boilers. Next type of boiler is Babcock and Wilcox water tube boilers. This is water tube boilers, right? If you see here there is a pressure gauge. This is a feed valve where water is fed into the drum. This is a drum, and this is the water area, and this is a steam area, steam space and water space. Here we are providing anti-priming pipe, and this is a main stop valve, right? And this is a one uptake header, and this is a downtake header. And here this is a baffle plate we are providing to control the flow of water over the flow of water. So it is a straight tube stationary type water tube boilers. It consists of a drum and connected a series of front end and back end header. See, there is a downtake header and uptake header by a short riser tubes. The water tubes are inclined. If you see here, the water tubes are inclined to the horizontal and connects to the uptake header to the downtake header. A hand hole is provided in the header. If you see here, a hand hole is provided to the header in front of each tubes for cleaning purposes, and a feed valve is provided to fill the drum. Here the providing feed valve, we are filling the drums, and inclined tubes with water, the level of which is indicated by the water level indicator. Though the fire door is the fuel is supplied to the through this fire door, the fuel is supplied to the grate where it is burnt. So due to the burning of fuel, hot gases is generated, right? And these hot gases are forced to move upwards between these tubes by baffle plates, right? And the water from the drum flows through these inclined tubes through this downtake header and goes back into the cell in the form of water through this uptake header, right? And the steam gets collected in the steam space here. Then the steam enters through this anti-priming pipe because the steam contains some moisture, right? If there is a moisture, then there is a maybe problem because this steam is going to the steam turbines. If it contains moisture content, it contains moisture, then it is very creating a problem in steam turbines. It damages the turbine blades. So to reduce the steam, reduce the moisture content in the steam, we are providing one anti-priming pipe, right? The steam then enters this anti-priming pipe and flows through this superheater, where it is superheated again to reduce the moisture content of the steam, and it is further heated and is finally taken through this main stop valve, and then it's supplied to the steam turbines when it is required. And the lower part of the boiler is provided there is a mud collector is there to to collect the mud particles after burning of fuels. So this is the working principle of Babcock and Wilcox water tube boilers. Next, Stirling boilers. So what is Stirling boilers? A Stirling boiler is a bent tube boilers which is externally fired. It is a stationary water tube boilers with natural circulation. This is the natural circulation boilers. It is a high pressure range of maximum 60 bar. It is a high pressure boiler. Sorry, maximum of 60 bars. It is a low pressure boiler which is below the 80 bars and a steam production of about 50,000 kg per hour. And the efficiency of Stirling boiler is up to 60 to 80%. If you see this boiler, this is a schematic diagram of boilers, right? This is a furnace, right? And this is a stop valve. This is a grate. This is called baffle valve. This is superheated tubes. It consists of two upper drums. If you see, there are two upper drums. One, two. Two upper drums are there, and both are called steam drums. And a lower drum is there. It's called water drum. And the steam drums are connected to the mud drum by bank of bent tubes. The steam drums are connected to this mud drum or water drums through these bent tubes. Now, feeding of water is done through this feed check valve to the steam drum 1 here, right, which then passes through these bent tubes to the mud drums. In the mud drum, the particles get settled down and they are removed through this blow-off valve at regular interval. Hence, the pure water passes through this bank of bent tubes to the other drums, which are just over the furnace. The steam is taken from the drum 1 through the steam pipe, right, and then it passes through the superheater tubes, where the steam is superheated. Finally, the steam moves to the stop valve, from where it can be supplied for further use. So this is all about Stirling boilers. Next boiler is La-Mont Boiler. This La-Mont Boiler is a high pressure boiler where this is a one type of forced circulation boilers, and this boiler working on forced circulation, and the circulation is maintained by a centrifugal pump driven by a steam turbines using steam from the boilers. If you see the feed water, this is a feed water where the water is passing through this economizer, right, to the drum. Here there is a drum. The feed water is passing through this economizer through this drum, where it is drawn to the circulating pump, and this pump delivers the feed water to the tube evaporating section, in which the mixture of steam and water to the in which this will provide the mixture of steam and water to the drum, and the steam in the drum then is again this drum should be superheated, and the steam in the drum is flowing through this superheaters, and the superheating steam so obtained is then supplied to the prime mover or steam turbines. This is called La-Mont boilers. Benson boiler is also one type of high pressure boilers. It is a drumless. Previously, if you see the La-Mont boiler, it is a drum, consists of drum. But in Benson boiler, it does not contain any drum. It is a drumless boilers. And water tube steam boilers using forced circulation. It is a forced circulation boilers. In this boiler, the feed water, if you see, enters into the economizer at one end and discharges superheated steam at the other end. And the feed pump increases the pressure of water to the supercritical pressure, that is above critical pressure of 225 bar, and thus the water directly transforms into the steam without boiling, right? And the feed water after circulation through these economic tubes flow through this radial parallel tubes section to evaporate shortly, right? Then the steam and water mixture then moves to the transit section. It will move to the transit section, where this mixture is converted into the steam, and the steam is now passed through this convection superheater and is finally to supply to the steam turbines. So this is the Benson boilers. So these are the boiler mountings already I have discussed. So what are the boiler mountings? Water level indicator. Now the function of water level indicator is to indicate the level of water in the boiler constantly. It is also called the water gauge, right? Normally, two water level indicators are fitted at the front end of the every boilers. Next one is pressure gauge. The function of a pressure gauge is to measure the pressure exerted inside the vessel. The gauge is usually mounted on the front top of the sail of the drum or the drum. It is usually constructed to indicate up to double the maximum working pressure. Next, safety valve. So what is the function of safety valve? The function of safety valve is to release the excess steam when the pressure of steam inside the boiler exceeds the rated pressure. As soon as the pressure of steam inside the boiler exceeds the rated pressure, the safety valve automatically opens, right? And the excess steam rushes into the atmosphere till the pressure drops down to the normal value. And the safety valve is generally mounted on the top of the sails. Then the most important mounting is the blow-off cock. The blow-off cock may discharge a portion of water when the boiler is in operation to blow out mud, scale, or sediments periodically. It may empty the boiler when necessary for cleaning and inspection purposes. So generally blow-off cock is used to cleaning purposes. Next, feed check valve. The function of this feed check valve to control the supply of water to the boilers and to prevent the escaping of water from the boiler when the pump pressure is less or the pump is stopped. The feed check valve is fitted in the water space of the boiler slightly below the normal level of the water. Stop valve. So what is the function of stop valve? The function of stop valve or junction valve, it is also called junction valve, to regulate the flow of steam from one steam pipe to other steam pipe or from the boiler to the steam pipe. So this is the function of steam valve. It regulates the flow of what? Steam. Next is boiler accessories. So as I have told, the boiler accessories is the most integral part of the boilers. So without boiler accessories, the boiler cannot work. So these are the most 4 important boiler accessories. First one is superheater. So what is superheater? It is the most important device of steam generating unit, right? Its purpose to increase the temperature of the saturated steam without raising its pressure. It is generally an integral part of the boiler, as I have told, and is placed in the path of the hot flue gases from the furnace and can be used both in fire tube boilers and water tube boilers. And the small boilers are not commonly provided with the superheaters. It requires large boilers. Superheater you have to use in a boiler if the boiler is a large, not for small boilers they are using. Next, air preheater. The function of air preheater of the boiler is to increase the temperature of air before it enters into the furnace. It is generally placed after the economizer. So before economizer, the aerator should be placed so that the flue gases pass through this economizer and then to the air preheater. Right. Then feed pump. What is the use of feed pump? The water in the boiler is continuously converted into steam, right? Which is used by the steam engines or steam turbines. Thus, a feed pump is required to deliver the water to the boilers. The feed pump is every time is required. The feed pump. It is regular intervals. It will feed the water to the boilers. And the last one, the boiler accessories is economizer. An economizer is a device used to heat the feed water by utilizing the heat in the exhaust flue gases before leaving through the chimney. As the name indicates, if you see, the economizer improves the economy of the steam boilers. So this is all about the steam boilers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.